So in this video lecture, I'm going to talk about motion generation and graphical approaches to that. We're going to start off with the simplest case, which is where we pick our moving pivots and then solve where our ground pivots will be. We'll start off doing this with just 2 positions, we'll move on to 3 positions, and then talk about some of the trade-offs as we add more precision positions. So taking a little step back, we have to have a drawing skill to be able to allow us to do this. And this is constructing perpendicular bisectors. And you might say, well, this sounds, very simple back in high school stuff. It is, but we need a quick review just so that you're on board with this. So the tools for this are a compass and a straight edge, and how you're going to use these is to find basically a line that perpendicular bisecting of 2 points. So I've got a point 1 and a point 2 here, these 2 blue dots on the screen, and I want to have a perpendicular bisecting line of these 2 dots. So what I do is I take my compass and I swing an arc that's greater than half the distance between those 2 points. So this would be swinging that arc from point 1. I would then swing an arc of the same length from position 2. And then once I have that, I basically find where do those 2 arcs intersect, and I draw a line between those 2 intersections. And then this red line here, this is a perpendicular bisector of points 1 and points 2. Very simple skill, but you're going to find we're going to use it quite a bit. If I add a 3rd point and now do perpendicular bisectors of multiple points, you can imagine that I would find the center of a circle that goes through 3 points. So a very useful skill as we're doing graphical synthesis. All right, so let's get to the actual problem at hand. Motion generation through 2 positions, and again, I'm going to pick my moving pivots here. So the application that I'm looking at here is a canoe loading mechanism. So imagine that I have a canoe in the stationary position on top of the vehicle, and then I want to have it in a more convenient loading position that perhaps I can load myself without a second person helping to lift it on top. Then I want a mechanism that brings it up to that stored position on top of the vehicle. Canoe, kayak, whatever this happens to be. I'm going to start by picking my moving pivots. So I'm going to pick that position A1 that I've shown at the upper right there of the kayak or the canoe. And then I'm going to say, all right, where does that A1 position go in the 2nd position? So I'll track that over and I'll label that position A2. So now I have these positions A1, A2, those are my moving pivots in the 1st and the 2nd position. Now I'm going to use these and construct a perpendicular bisector of them. So I've got an arc from A1, I'm going to then have an arc from A2, and then create this perpendicular bisector between those 2. And what I'm going to find is that any location on this perpendicular bisector, I can arbitrarily say, let me place a ground pivot, maybe right here, and by doing so, I now know that any location along that line is going to be equidistant between A1 and A2, and so I can have a link that goes there, and then that will swing from that position and swing through an arc all the way getting over to this position over here to A2. So any location on that line will satisfy that, and I'm able then to come up with a synthesized solution for this one side of the mechanism. Recognize that I don't yet have a 4-bar, so I still have to do this with the other side of my mechanism, but I'd have half the solution. All right, so I've got this A side, and I'm going to leave that perpendicular bisector in place. And now let me attack the B side of the mechanism, or the other half of my 4-bar mechanism. Just like I did for the A side, I'm going to pick a moving pivot. I place it at B1 there, and then I'm going to track it to where it goes in its 2nd position, so B2. I again swing these arcs to create a perpendicular bisector, and that's the red line here. Now, one thing that you'll note is that these two bisectors, the ones for the A side of the mechanism, the blue line, and the ones for the B side of the mechanism, they both intersect at one location here. Now, this is a very interesting location in that if I set up a ground pivot right here, and then I rigidly connect that to my kayak, and this then becomes a 2-bar mechanism, and I have ground and then this one location that I'm pivoting. This is the center of a pivot from position 1 to position 2, and we call this a rotopole. And we'll use that later on in the course in quite a few specific applications. But that is a rotopole between position 1 and position 2, and that would allow me to form just a 2-bar mechanism. That's not what I want here, but it is a useful position that we'll talk about later. So that's my rotopole. But let me clear that off and now say, for this mechanism where I have these 2 perpendicular bisectors, I can create a 4-bar mechanism. Again, for the A side, I had picked a ground pivot down here, and I would typically call that A0. And I can connect that up to my A1 location, so that would be one link of my mechanism. And then I can do the same thing for the B side of the mechanism, and perhaps I want to place a pivot, let's say right off the vehicle here, and now I can connect that to B1. So that will be my pivot B naught right there. And now this 4-bar mechanism where the 4th bar is really this canoe holder right here, so that would be grabbing through those 2 pivots. This piece holding the canoe is my coupler. This 4-bar mechanism will guide me from position 1 to position 2. Hopefully I don't have any circuit or branch defects and that it will smoothly go from position 1 to position 2, but it will at least hit those 2 positions, and that's what my synthesis procedure allows me to guarantee. All right, so with that said, let's move beyond just this 2-position problem. One challenge often with 2 positions is that I might have some intermediate motion that I don't like. Imagine that this canoe perhaps hits the side of the vehicle as I'm unloading it. Or perhaps I don't like the way that it's rotating as it goes between these positions. Something about it is not very beneficial. What I can often do then is add some intermediate guiding positions. So here I've gone to a 3-position problem with an intermediate guiding position that will hopefully prevent me from hitting the vehicle as I'm unloading it or loading it. So I've added this 3rd precision position. Now my approach here is very similar to the 2-position problem, except I'm now going to have this 3rd position and therefore have to do 2 perpendicular bisectors for each side of the mechanism. Let me start off for the A side again. So I'm going to pick that A1 pivot, very similar to what I did before, and I'm going to say where is that then in the 2nd position and the 3rd position. So that's all those blue dots, A1, A2, and A3. I'm going to construct perpendicular bisectors again. So I've got an arc from A1, I've got an arc from A2. Those 2 will then form one perpendicular bisector. I then have another arc that I can swing from A3, and I see that it intersects my arc from A1, and I can then swing or draw a line between those, and that is my 2nd perpendicular bisector. So from all of this then I can say these 2 perpendicular bisectors intersect each other at one location, and then that is the center of an arc that runs through A1, A2, and A3, and hence that would be my ground pivot location for that input side of my mechanism, or the A side of my mechanism. So now I have 1/2 of my 4-bar mechanism for 3 positions, and that, you can imagine, I have this arc here that's going to swing through this position A1. As it keeps moving, it'll go through A2, and as it keeps going, it'll get all the way over here to A3. So that is what I've done with this synthesis process. I have to do the same thing for the B side to actually create a 4-bar mechanism. And here I've placed my B1 pivot a little bit arbitrarily and then tracked where it went in B2 and B3. Again, these are free choices as to where I place these moving pivots. This is up to me as a designer. So I've placed that B1 pivot, tracked it to B1 and B2. Just like I did for the A side, I'm going to construct perpendicular bisectors and find the center of those bisectors, and then that gives me this solution right here. And I kind of skipped the pieces of it that I just went through, but you can see that this B1, as it swings about this pivot B naught, will go through B2 and then eventually over here to B3. So this is a 4-bar solution for this problem. Well, where's the 4th bar? I still have to have this piece here that holds the kayak or the canoe, and that's maybe something that looks like this, somehow grips onto the canoe, has those 2 moving pivots, A1 and B1 on it, and it will take it through those 3 positions. So this allows us to do 3-position motion generation, and one thing that you'll notice is that because we now have these 2 perpendicular bisectors defining where the ground pivot is, I lose one of my free choices. So I want to take a step back and kind of look at what is the influence of how many free choices versus how many precision positions we have. So we started off by having 2 precision positions, and my free choices in this case were the X and the Y positions of my moving pivots. And so this was really, each one of these, if I focus on just one dyad of the mechanism, which is 1/2 of the mechanism at a time, so the A side of the mechanism, I've got the X and Y, and then I constructed that one perpendicular bisector, and I picked where did I want my ground pivot on that perpendicular bisector. So I also then had the location on the perpendicular bisector. So from these, then I had a total of 3 free choices for each side of the mechanism. So 2 positions, 3 free choices. I then went to 3 precision positions. I still have the X and the Y of the moving pivots. That was my free choice as a designer. But I no longer have a choice as to where I am on the perpendicular bisector because I have now 2 bisectors that intersect at one location, and that's the location of my ground pivot. So I had 3 free choices previously. I've now dropped this down to 2 free choices by going to an extra precision position. Now you can kind of see where this is going. If I added a fourth precision position, I'm going to drop my free choices to 1, and eventually I could actually go to 5 precision positions and have no free choices to make, but I could have a solution. But you'll see that the approach that I used here is not conducive to going to 4 positions or 5 positions, and we're going to find that graphical synthesis is very difficult to do to 4 or 5 positions. There is a technique to do it for 4 positions, but it's really not worthwhile. So instead, we're going to tackle 4 and 5 positions later when we get to analytical synthesis techniques. So, quick summary here, we've talked about graphical synthesis for motion generation in 2 positions and 3 positions where we're picking our moving pivots, and then looked at these trade-offs. As we add additional precision positions, we reduce the number of free choices we have as a designer.